Combustion reaction. This is the reaction we're talking about for the energy needs. Combustion means the burning of petrochemicals, students. In general, the burning of petrochemicals in the presence of oxygen is called as combustion reaction, burning reaction. Why do we need to burn these petrochemicals? Not only petrochemicals in the sense like all the hydrocarbon related compounds, even wood also. So fuel, mostly that is used as a fuel. So the carbon dioxide gas and water vapor formed are released in the air. The heat energy released is put for various domestic as well as industrial uses. The energy which is used for cooking also, the energy which is used for transportation also, yes or no? So this is a reaction, fuel, whatever the fuel, hydrocarbon plus oxygen gives us carbon dioxide plus water vapor. For example, if it is a methane, CH4 plus 2O2 gives rise to CO2 plus 2H2O. So what are the components, common components which are released after combustion? Carbon dioxide and water vapor. So that's why what the scientists are saying, we have to reduce the carbon dioxide emissions, carbon emissions, yes or no? That means we have to reduce burning fossil fuels. Why? Because if the carbon dioxide levels increases, in the beginning I have said, what is the nature of CO2? It traps the heat energy. If more CO2, more heat energy, then what happens? The temperature of the globe will increase, yes or no? That leads to global warming. That leads to global warming. Sir, what happens? If temperature rises, what happens? Polar caps will melt, that rises the sea level, and the devastating effects, students, completely weather patterns will change, everything will be collapsed. So chemical properties of oxygen, students. So oxygen is a good supporter of combustion, correct? Oxygen is a good supporter of combustion. That means all these burning reactions takes place in the presence of oxygen. It means if it is a hydrocarbon, carbon in presence of oxygen, it burns, that means it releases energy and converts into carbon dioxide. That means it is a supporter, supporting the combustion or not. So these combustion reactions are taking place in the presence of oxygen. Oxygen gas is a supporter of combustion, but itself it is not undergoing combustion. It is not combustible itself. That means take oxygen gas and burn something. Why taking oxygen gas? Burn something in the air. It contains 21% oxygen, right? Is oxygen gas undergoing combustion? All the oxygen in the air, is it burning? No. What does it mean? Oxygen gas is not undergoing combustion. It is supporting the material which is undergoing combustion. Understood? How it is supporting, sir? It is supporting means it is helping to combine with that element in the presence of oxygen. C becomes CO2. Understood? And it is releasing energy in this process of combination. So right, metals react with oxygen to form their respective basic oxides. In the beginning, in the previous slides also I have said, when metals combines with oxygen, what do they form? The respective metallic oxides. You can check the formula, students. The formulas depends upon the valencies of the particular metal. When sodium combines with oxygen, what does it form? Sodium oxide. If magnesium combines, magnesium oxide. Iron combines, iron oxide. In all these three reactions, all are oxides, metallic oxides. Yes, sir. Now, what is the nature of these metallic oxides? They are basic in nature. When these metallic oxides, when they dissolve in water, they form hydroxides, which are direct bases. Yes or no? Right. So non-metals such as carbon, sulfur, phosphorus react with oxygen and they form the respective non-metallic oxides. With these non-metallic oxides are acidic oxides, students. Carbon plus oxygen, C plus O2 gives rise to CO2. Sulfur plus oxygen gives rise to sulfur dioxide, SO2. Phosphorus plus oxygen gives rise to P2O5, phosphorus pentoxide. All these, what is the common thing? All these are non-metals, yes or no? So these are acidic oxides. You already know the litmus color change in these acidic oxides. So when these acidic oxides, students, when they dissolve in water, they form direct acids. CO2 plus H2O gives rise to H2CO3, carbonic acid. SO2 plus H2O gives rise to sulfurous acid or sulfuric acid also if it is SO3. P2O5 in H2O gives rise to phosphoric acid, phosphorus acid. Like that, these non-metallic oxides, when added to water, they form the respective acids. So oxygen, when it reacts with metal, it produces metallic oxides which are bases. When it reacts with non-metals, it produces non-metallic oxides which are acids. Next, uses of oxygen. Like what are the uses? What are the general uses? Oxygen in the air is continuously used by human beings and animals for breathing. Yes or no? That is the essential thing, continuously happens. So Atmospheric oxygen is also being used for burning wood and fossil fuels, right? For burning reactions, like many times we discussed about this point. Oxygen is one of the key element for burning, right? So pure oxygen is used by the deep sea divers, mountaineers and aviators and miners for safety. Miners means like coal mines underground, which used to collect the mines, yes or no? So where the percentage of oxygen is less, they use. And submarines, mountainous, where if you go to the higher altitudes, again oxygen will be less, though they use this oxygen cylinders, right? In the space industry also, oxygen cylinder for breathing purpose only, right? So in the medical industry also it is used, right, students? So oxygen is used in chemical industry for making acids and other compounds as oxides, right? For making acids, right? Just now in the previous slide we discussed, when non-metals, when they combine with this oxygen, they produce the respective non-metallic oxides, and these oxides, when they combine with water, they produce acids. Sir, what are the use of acids? Many uses are there. Acids, they release H plus ions. These acids are mostly used as a reagents in the organic synthesis reactions. So it is used to burn fossil fuels for energy, same point. So importance of oxygen in the combustion of all the forms of fuels. Fuel, what is the fuel? If you want to define a fuel, the component which gives us energy while burning. Any material which burns in air or oxygen with a release of large amount of heat energy and light energy is called as a fuel. What are the general fuels? In the olden days, nowadays we are using petrol, diesel and kerosene, oil, LPG and CNG, yes or no? In the olden days, what is the fuel? Like what is the source for the fuel? Wood, yes or no? Or old, and not only old ancestors, 3 generations back, 2 generations back, our grandfathers, grandparents, what do they use for cooking? They used to collect the dried out wooden logs, wooden stems, yes or no, students? And while burning, that is combustion reaction. And what that wood contains? Hydrocarbons only, not only carbon and hydrogen, oxygen, other elements also, but mainly hydrocarbons. They releases also smoke that contains carbon dioxide, of course insufficient combustion, pure carbon also there, and water vapor is released in this reaction. That is common, students. CO2 and H2O after combustion. All these look at here, wood, coal, kerosene oil, LPG, CNG. What is the common thing in all this? They're all hydrocarbons, which means all these components, all these substances, they're made up of carbon and hydrogen. Sir, if they're made up of carbon and hydrogen are the same? No. Different compounds, right, students? For example, CNG, it contains mainly methane. LPG, it contains butane. Kerosene oil, it contains a mixture of different hydrocarbons like propane and all these components. Coal is also almost pure form of carbon, yes, a powdery substance. All are carbon ultimately, but carbon, there is single compound or many compounds are there. Thousands, lakhs of carbon compounds are there. So first wood. Wood is used in the rural India also in the students. It is even nowadays also used in the rural India. Where for what purpose? For cooking, for the energy needs. Wood is used. And not only wood, students, if you go to the rural parts of the India, we even use the dried cow dung. Yes or no? They are called as cow dung cakes for cooking purpose. So that's how. Coal, where the coal is used. So before discovering all these petrochemicals, coal is widely used for the energy purpose, even in the industries, not for even cooking also. For example, barbecues and all. How do they do with that coal, with the charcoal? Yes, students. So mostly the general use industries. Steam engines. Have you seen in the old movies or general? Nowadays they are very rare. Steam engines. How do they work? Rail engines, railway. Like with the coal, with the by burning this coal, ultimately for what purpose? Burning only. It's a coal, where it is available as a coal mine. Yes or no? Over millions of years ago, the dead vegetation was buried under the earth crust. Under high temperature and pressure, it becomes into coal. So that coal is also used as a fuel. Mostly it is used in the industries for electricity generation. Everything coal is being used. And kerosene oil. Where kerosene oil is used? Mainly for lamps, some kind of stoves are there. So there we use kerosene oil. And LPG, liquefied petroleum gas. Nowadays we are using LPG cylinders only. Gas cylinders, right, students? It contains mainly butane, propane and all. It's a mixture of different gases. So LPG liquefied, why? Because under high pressure condition, this gas was stored in a cylinder, so that when you open it, it directly comes out and we'll burning it. Yes, sir, on the gas stove, it's a burning reaction. So LPG and CNG. So here some have doubt. Sir, it is not giving the smoke, it is not releasing. It is releasing, students. But when you see the smoke, that means it is insufficient combustion. That is insufficient combustion. Listen, three types are there: solids, liquid, gases. Solid, wood; liquids, petrol, kerosene; gas, LPG, CNG. Gas fuel, gaseous hydrocarbons are the cleaner fuels comparatively. Why? Because they undergo combustion completely. Solid and liquefied, they undergo combustion, not completely, insufficient combustion. That's where the smoke is coming. Understood? That's the difference. That doesn't mean CO2, sir. In my gas stove, see, nothing is getting, don't think. It is released, but you can't see it. Why? Because carbon dioxide is also a colorless. CNG, compressed natural gas, it is mostly used for vehicles. Yes or no? It contains mostly methane. It is also used for students burning, for cooking also. Mostly nowadays it is used as a fuel for transportation, right? CNG autos, CNG vehicles, CNG cars are there, right? So these are the components. Rusting of iron. So what is rusting? So why rusting comes here? Why? Because this rusting also takes place in the presence of oxygen only, student. That means the metal surface, the cleaner metal surface, when it is exposed to the oxygen and water, H2, water vapor or water, it undergoes rusting. That means the surface metal undergoes oxidation and it converts into the respective oxide. That is called as rusting. In the if it happens in the case of iron, that is called as rusting of iron. Iron converts into iron oxide. That iron oxide is called as rust. Rust is a compound formed by the action of oxygen on iron in the presence of water. Look at this. Look at this image. This is, everyone knows, right? The brown color flaky substance is called as rust. If you scratch it, of course, don't do that. It's not good. It leads to septic also. It falls off. Yes, sir, students. So ultimately, what will happen? You can find a hole in some years. Why? Because slowly, if this substance falls down, again that exposes new metal inside. That undergo rust, falls out. That again new material, new metal exposed. That undergoes rust. It's a continuous process. Ultimately, hole will appear. Right? That weakens the quality of the iron. First of all, iron gone into iron oxide. So conditions necessary for rusting. The conditions that are necessary for rusting are presence of moisture, oxygen and water vapor. Iron, oxygen and water. Iron is the main, and in the presence of oxygen and H2O, this rusting takes place, students. So what are the preventions of rusting? Like, how can we prevent? Why do we need to prevent? Just now I have told you. If rusting happens, that reduces the quality of iron. Iron only itself, it's gone, right, students? Why? Because rust is a flaky powdery substance. When it forms rust, the rust falls down. That exposes new iron and continuously hole will appear. Painting. This is one of the technique. Mostly our two-wheeler, four-wheeler, the bodies of iron bodies are painted, yes or no? Painted with different colors, of course, for good looking as well as to avoid rusting also. Your school van, you know, it is made up of iron only, complete body of the van. It is painted, yes or no? Some case where the paint is gone, you can see the rust there. So because of the painting, the iron is not exposed to the atmosphere, water vapor and oxygen. So we can avoid rusting. So galvanization, this is one of the key process, students. Galvanization means coating the iron with zinc. That is called as galvanized iron. Why is that coat? We have paint now. Why iron? Why? Because, students, in some cases, for example, a bridge is there, iron bridge is there. If you paint that iron bridge, over some years of time, what will happen? This paint will also falls down. Yes, sir. Why? Because it will go during some years, it will be falls down. Again, that exposes iron. Yes, sir. No. If you want to paint that bridge again, that's a big process. So if you can coat that iron with a metal, which if this metal is not a highly reactive metal, but if it forms the oxide layer also, that's not a flaky substance like iron oxide, like rust. So for example, zinc. Coating iron with zinc. Have you seen the railway bridges? What is the color of railway bridges or the poles near the railway lines? It is silvery color, no, that is galvanized iron. Student, that is galvanized iron. Mostly these water pumps are there, students, which we used to transport for water. So that is GI pipes. What is the meaning? Galvanized iron. Understood? So ultimately, to prevent rusting, to avoid rusting, we used to galvanize. What is galvanization? Coating zinc on the surface of the iron, which prevents exposure of iron. Tin coating also the same reason, coating with tin in the case of tin. Chrome plating. Chromium, coating with chromium, students. Chromium is a, it looks like stainless steel, a glossy stainless steel. For example, bicycle handles or taps. Have you seen the taps also looks like steel? That is also coating of iron on with chromium, as well as taps, bicycle, as well as door handles also. Have you seen the door handles? Sometimes they are steel, sometimes they are chrome plated iron only. So for good looking purpose, we used to follow this method. Ultimately, all these techniques are to avoid iron to undergo rusting. Alloying, this is one of the crucial things, students. Alloying means mixture of different metals. It is also mixture, like stainless steel. We all know stainless steel, yes or no? So is it a single element? No. Steel is a combination. Steel is a mixture of different metals like iron, chromium, nickel. Not only metals, even carbon, non-metal also, students. Why alloying? For example, students, iron undergoes rust. Okay, steel, does it undergoes rust? No. Why? Because the arrangement of atoms in all these of different metals makes that particular composition, gives very strongness, tensile strength, as well as it gives some kind of unreactivity also. So that's why the mixture of different metals is called as alloying, and the respective alloy is strong than its metal, as it is unreactive than its metal also, respective metal also. So alloying also, which is used to prevent rusting. So that's it, students, about oxygen, the uses, as well as first of all the air, the properties of air, oxygen, physical properties, chemical properties, and rusting, and all the techniques. So I hope you got the clarity about this oxygen, and a nitrogen water vapor we'll discuss in the coming video. Thank you, students.